Okay, I'm going to do 3.13 on page 39 in your physics book, or at least that's what page it is on in this year, 2020. Um, so it's a kind of the nightmare inclined plane problem. So you can do this, you can do anything on the JEDI trial. So we're going to make a drawing here of our inclined plane. And the angle of the inclined plane is 15 degrees. There's a box or a lawnmower. What is it? It's a box. And someone up here is pulling on the box like with a rope at a angle. And someone is behind it trying to push the box up the hill down at an angle like this. Okay, and this let's see, pushing at an angle of 17 degrees. So this is 17 degrees. And this one is at 10 degrees. Don't worry that I didn't draw them out that great. Okay. So what else do we have? We have a normal force going up like this. And we have, this way we have force of gravity times cosine of theta. The force that this person's pulling is F. We don't know what it is. They gave us no numbers for it. Okay. Move it up here a little bit. Okay. And this one here is exerting the exact same amount of force. So we can put F for that too. Both these are the same number. So we just put an F for both of those. Okay. What do we got? Well, we always have the weight component going down. So Fg sine of theta going down like this. Now what we have to do with this is we have to resolve both of these forces into, this one would be going something down and over like this. And this one would be going like over and up like so. Okay. So what will this be? We don't actually know what F is, so we have to kind of leave these in terms of F. So this would be F sine of 10. This would be F cosine of 10. This one here would be F cosine of 17. And this would be F sine of 17. Okay. I think we have everything we need there. So this is being accelerated upwards, okay? Being accelerated upwards at a rate of 1 meter per second squared. So my acceleration is 1 meter per second squared, it says. The mass of the box is 60 kilograms. What else do we have? Mu is 0.100, okay? And we're trying to figure out what are the F's, what are the forces right there. Okay. If the mass is 60, that means the force of gravity or the weight of the box is 60 times 9.81. So I do 60 times 9.81. And I got a force of gravity of, I'm just going to call it 589 newtons. Okay, we'll just call it that. Okay, so what happens here? Okay, so we have, let's look at all the y forces, the ones going out of the inclined plane or into the inclined plane. So we have one over here, it's going into the inclined plane, down. We have one here, it's going down. We have one here, it's going up. We have one here, it's going up. Now we know that in this direction, everything has to be in equilibrium. Okay, so they all have to be balanced up. So my up, these two added together need to equal these two added together. And I can draw that. I can do that under here. I can say Fn plus F sine of 10 should equal F sine of 17 plus Fg cosine theta. Okay, now Fg is 589. So I'm going to put 589 in for that. So plus 589 cosine of theta, and this theta is this degree here, so it's 15. Okay. All right. So that means then that Fn should equal 589 cosine 15 plus f sine of 17, and then I can take this over minus f sine of 10. Okay, so there's my Fn. I can simplify this a little bit because I can figure out a number right here for this first part. So it'd be 589 times 15 cosine equals, and that's 569. So this is 569 plus f sine of 17 minus f sine of 10. Okay, so right now I have a normal force. Yeah, that's all I did is a normal force. Okay, so now I need to do a really nasty, ugly derivation. I know that this is accelerating up, which means that there is some net force. So I'm going to start my derivation with F net equals MA. Okay, F net equals MA. All right, what is F net? Well, I have a force going up the inclined plane. I have another force going up the inclined plane. I have a force going down the inclined plane. And I have one more force that I didn't even draw on here yet. My FBD wasn't completely correct. I have going down, I have friction force, which is mu Fn. Okay, I have friction force, which is mu Fn. Okay, so what do I know? I know that there's net force going up because it's accelerating up, which means this plus this is bigger than this plus this. Okay, so to find my net force, I'm going to have to take this plus this minus this and minus this. Okay, all right, and that all will equal MA. Okay, now we actually know what MA is already. MA, the mass is 60 and the acceleration is 1. So that F net, I'll erase that MA, that F net is going to equal 60. All right, so let's write out our starting equation. So F net is going to be this force, F cosine 10 plus this force, F cosine 17. Those are both the forces going up. Now I'm going to subtract out this force minus Fg sine of theta. Now Fg is 589, so 589 sine of theta, okay? And minus mu Fn. That should equal, that's my net force, and that should equal then 60. Didn't show it there. Okay. All right. So I really don't need the inclined plane anymore. So I'm going to kind of keep moving this down here because I have everything I need to do. And I'm trying to solve for this F right here, that force. Okay. All right. So this is going to get really bad. So I'm going to do this. I'm going to do F cosine 10 plus F cosine 17 minus, let's just do a number here because I know what this is. This was the friction force, or the parallel, this one right here, the parallel component of the weight. Okay, so that's sine of 15. So I'm going to do 589 times 15 sine, and I'm going to get a number here already. So minus 152.4, we'll say. Okay, minus mu times Fn. By the way, we know what mu is too, so I can, instead of mu, I can put 0.1, minus 0.1 times Fn. What is Fn? Well, Fn is this whole thing right here. Look at that. See how nasty it's going to be? There's my entire normal force. So in for this Fn, I need to put this. So it's going to be minus 0.1 times the quantity 569 plus F sine of 17 minus F sine of 10. That all goes in for Fn. Okay. All right. So let's do some numbers here. So cosine of 10 cosine is 0.985. So this is going to be, we're going to call this 0.985 F. Okay. Plus 17 cosine is 0.956. So this is going to be plus 0.956 F. Okay. Minus 152.4 minus 0.1 times 569. 569 times 0.1 should just move the decimal over. So this is going to be a minus 56.9. Oh, by the way, this whole thing, right, equals 60, right? Because I just put this whole thing in for the Fn. So that whole thing equals the net force, which was m times a, mass times a, 60. Okay. All right. So this minus 0.1 times that. So I take a minus 0.1 times this. And so I'm going to do 17 sine times minus 0.1 is going to be a minus 0.0292 F. Okay. And then I'm going to take a minus times a minus. So that's going to be a plus. So this is going to be a plus 10 sine times 0.1 is 0.0174 F. Okay. And then that equals 60. All right. So what we're going to do is we're going to combine all the F terms, right? So I have 0.985 F plus 0.956 F minus 0.0292 F plus 0.0174 F equals, and I get 1.93 F equals, I'm going to take all the numbers, all this part, I'm going to take it over the other side. So it'd be 60 plus 152.4 plus 56.9 equals, and I get on this side a 269.3. So the force should equal 269.3 divided by 1.93. Okay. So 269.3 divided by 1.93 equals, and I get like 140 newtons. QED. So back up here, these two forces right here, each of these forces are actually both 140 newtons. Okay. That was a fun one. That's how you do it. Hopefully that made some sense.